Warm greetings and very good morning, dear friends and students. Today we are going to see about the method of deflection and why we have to go for to find the deflection of any types of beams, either cantilever, simply supported, or the overhanging beam, or a fixed beam, either determinate or indeterminate beam. Because the deflection plays a major role in having the check for the serviceability conditions as per the IS code. So in the case of either steel structure or RCC structures, the deflection of beams plays a vital role. In the case of RCC, the case of limit state method, we are having the limit state of serviceability to find the deflection and also the cracks, which is the permissible limit as per the IS code. So based on that only we have to go for the design of the any structures, either RCC structure or steel structures. So in the case of RCC or the steel structures, the maximum deflection should not exceed the span of the beam divided by 800. So that is where L is the span of the beam. For example, if a simply supported beam was 5 meters, so 5000 mm divided by 800. So the deflection should not exceed this limit. So this plays a vital role in the case of any RCC structural design or the steel structural design. Now we are going to see the method of deflections. The various method of deflections are the double integration method. The second one is McCullis method. Third one is moment area method or area moment method. And the fourth method, which is called as the conjugate beam method. In addition to that, we can go for the strain energy method also. So this plays a vital role in determining the deflection or the slope. The slope can be measured in terms of radians. If you want, you can convert in terms of degree. That is by multiplying 1 degree is equal to pi by 180 radian. So here, whenever the beam is subject to a different type of loads like UDL, point load, UVL, or the combination of point load and UDL, or the combination of UDL, point load, and the uniformly varying load. How the deflection and the slope can be measured by using the different methods. So here, these 5 methods cannot be utilized for all the beams in all conditions. So based on the conditions and the type of beams and the type of loading, you can choose the corresponding method to find the slope and deflection of beams. For example, the double integration method can be used if the beam is of simply supported or cantilever type, which is having a simple loading, either point load and UDL throughout. There is no discontinuous UDL. So in that case, you can use the double integration method. But in the case of McCullis method, so it is a modification of double integration method. You can apply for the different type of loadings like the discontinuous load, 1 point load and partial UDL, or point load, UDL and UVL. You can apply for this McCullis method. But in the case of moment area method or Morse theorem method, if the loading is simple and the fluxual rigidity of the beam, that is EA, is different, you cannot use the first method and second method is double integration method and McCullis method. So then you have to go for the moment area method or Morse theorem method. So in the case of conjugate beam method, the fourth method, if EI is also varying and the loading is simple loading and some simple partial UDL, you can apply for this method, that is the conjugate B method. So the synergy method can be used for the simple method, simple loading, and also for the simple supported cantilever and overhanging beam. So you cannot apply for the different cross section of the beam, and EA is varying. The synergy method will be a different one, and it's a more cumbersome method. So based on the type of loading and the type of beams, you can choose the particular type of methods to find the slope and deflection of the beam. So this is about the main introduction of the deflection of beams and what are the methods are applied in the case of finding the slope and deflection of beams. The next video we can see how the slope and deflection can be find out by using the double integration method and the which is called as Macaulay's method. It is the modification of double integration method. Thank you very much for patient listening. வாழ்க வையகம் வாழ்க வளமுடன்.